Welcome to this presentation. My name is Mark Scythian. The date today is February 12th, 2025. The title of this presentation is How to Detect and Evade an Incoming Tornado. I missed the two there. I'll correct that in a second. All right, so here's the method to really detect a tornado before it becomes a problem is find out your elevation, and for every 1,000 feet above mean sea level, up to 12,500 feet above mean sea level, you will lose 1 inch of mercury on the barometric reading. So the mean sea level atmospheric pressure, 14.7 pounds per square inch, is equal to 29.92 inches of mercury. So in this case, we can subtract 0.95 from the mean sea level barometric pressure reading and calculate 28.97 inches. So just subtract in increments of 1,000 1 inch from the 29.92 inches of mercury mean sea level reading. And so you should get a normal barometric pressure reading at, let's say, your elevation, whatever it is. Most residences are elevated above mean sea level about 800 to 1,000 feet above mean sea level. So I'm just taking an average value. So you'll get a normalized barometric pressure reading of 20, in this case 28.97 inches of mercury Hg. So there's negative 1 inch of mercury per 1,000 feet elevation above mean sea level, up to 12,500 feet, and then we go into a logarithmic calculation. So most houses are from sea level to 12,500 feet, so it works. And if you're at, like, say, Denver, Colorado, mile high city, you'll have to subtract about 5 inches of mercury from 29.92. However, you can just use Google and look up the barometric pressure reading at your location. Okay, so again, barometric pressure readings can also have deviations based on cold, stationary, and warm fronts. So it's just better to use a barometer or use Google barometer and your phone, whatever. So this is really easy to get now in the digital information age, whatever. So find that barometric pressure reading. So if there is a tornado coming, you should have already been warned. You're going to see adverse weather. You're not sure. Well, you know something's coming. You're just not sure if it's a tornado. You haven't seen any twisters, any funnel clouds, but go to your barometer and look for a sudden drop in the atmospheric pressure. So we call this the sudden drop in barometric pressure. So again, the tornado, as you know, is a vertical low pressure medium. So now it's going to suck in all this air from the surrounding region. And so it's like picturing water as a fluid, because air is a fluid. Any substance that takes the shape of a container is a fluid. So that's gases and liquids. Fluid mechanics, right? So imagine you have a bathtub drain and you have a full bathtub, and then you open the drain. You're going to create a low pressure vortex that goes into the drain. Think of that as a tornado, sort of, right? So if you really actually have a tornado coming close to you, which obviously the weather's terrible and the winds are high and it's raining and you're not sure if it's actual tornado, look at that barometer. If it starts to drop to some crazy 5-6 inches negative to where it is, you're more likely have a tornado coming in. So that's in case if your early warning tornado system doesn't work or somebody made a mistake. You can't just like say, oh, we're going to use the TV to. No, you can use the weather app, or you can go to Google and type in, it's probably already, when you go online, it'll track your location and say, there's a tornado coming in. You probably just use Google nowadays. But just in case you're not doing that, get the barometric pressure, or just get a barometer in your house, analog or digital, whatever. You see that barometer dropping. That's a lot of air to suddenly lose its pressure there is definitely some sort of a vortex or tornado in the area. And so, incoming, we got a tornado. So what do? Okay, so now you confirmed, you detected you have a tornado coming in. It should be known that the pre-tornado fluid mechanics, airflow mechanics, aerodynamics, etc., is going to push a high pressure center of air, which forms a boundary layer that takes the shape kind of the ground level. I mean, it has a lamination, or it has a thickening boundary layer, and this will kind of swoop upward and create a sudden low pressure condition at higher altitudes. And then the tornado is kind of like the side effect of the electrostatic fields in the air. And the air undergoes ionization, and it always does before rain and lightning. But the type of ionization is pursuant to the electrical eddy currents that build up in the air. So that's kind of a unique, almost knowable, but highly abstract tracking method. So it's not just, oh, we can throw some eddy currents in the air, or we can create a little mini tornado. It does not work that way. And so it's really unknown what forms into a tornado other than the electrical fields just concentrate. And there's probably a lot of non-scientific accuracy on how tornadoes form. And there's probably a lot of people outside of science and engineering and physics that probably actually know how they work. But we're talking in terms of like mathematics. Science is nothing without mathematics. So just because something can't be proven doesn't mean it's not true. So that's the limitation of science, is that everything has to be proven with math, or else it's not scientific. But it doesn't mean it's not true. It could be true maybe from other points of view, like certain peoples and cultures know what the tornado is, and it's probably not even on topic. So anyway, that's just the observation if we keep it really conservative and see eddy currents and high pressure boundary layers occur with respect to high altitude and ground level. So obviously there is a standing boundary layer that thus reaches a vertical path, and then it's like sort of directing the air like you would direct the water in the bathtub when the drain's open. So obviously we have tornadoes. They're not theories. They actually exist, right? And so there's this angular airflow boundary layer that develops into a congruence with the electrostatic eddy currents. And that's just the observation. There's a lot of 3D modeling and aerodynamics labs about what is the pre-tornado, I would say, precursor that can be repeated over and over and over. And that's kind of like the closest that is like the closest research to predicting a tornado, because sometimes they just occur, to just manifest, and then they're gone, right? So you don't want to like say this is what causes the tornado. It's kind of unknown, but so far I would say a hypothesis would articulate pre-tornado eddy currents and the ionization of the electrostatic field, and then the air starts to form in the method of electrostatic eddy currents, right? So we call it congruence with electrostatic eddy currents. So that's just some food for thought. And so the presentation's about how to detect and evade an incoming tornado. So that's like kind of like the general familiarization of the tornado's development and its repeatable reaction with respect to atmospheric pressure. It's the sudden drop in barometric pressure. So keep an eye for that one. Keep an eye on barometric pressure, sudden drop. And then if we look at the average E3 tornado, which is pretty much the common ones, and they're not weak, they're pretty severe, but not as horrible as an E5. You have about a 1,200 foot altitude and an 800 foot diameter on average. It's effective height and diameter, so that's a 400 foot radius on either end. And then we have a rotational speed of about 150 miles per hour. So that's a lot of 100. There's like, I have another video that actually quantified the mass airflow in weight. But if we put it all together, there's just massive amount of mass airflow rotating at 150 miles per hour, and it's massive because of the diameter and the height. We have a huge amount of volume rotating, a huge amount of volume of air rotating. So through the metrics, there's about 138 billion watts of power in a typical E3 tornado. So just to get an eye of what the tornado is, and people see them on YouTube or on TV, and then some people experience them quite often in like Tornado Alley in Middle America, and they know all about these tornadoes, and they're nothing to really, they're not something to take lightly at all, right? So, but there are some advantages you have when dealing with tornadoes, and tornadoes only move across the ground. It's linear speed of about 35 miles per hour. So they rotate at about 150 miles per hour, but they move across the ground at about 35 miles per hour. So that's the advantage. So if a tornado is incoming and you can't get underground and it's coming at you, you can see it half a mile out. I mean, you literally could drive away from it fast enough and get into the next town and escape it. So that's a huge advantage of tornadoes. If you detect them ahead of time, you have enough. If you have a mobility to drive out of there away from it without getting hit by debris, it'd probably be a better risk to take. However, going below ground is the default countermeasure to at least survive a tornado, if not evade it completely. So you go below ground, open the windows of the house or the house you live in to alleviate exterior air pressure. So think about it. You got all this air flow, and probably if your house is in the tornado's path, it's just going to get destroyed. There's no compromise on that. But if it's close to your house and the air pressure is extreme, many times the air pressure builds up against the exterior of the house, and we have to assume at least the drag coefficient of 1.0 because it's a flat surface. The windows will start to accumulate pressure and just shatter, or if not shatter, other parts of your house will fall apart if not on the path of the tornado. So venting your house by opening up the windows a little bit, don't have to be all the way open, just cracking them open a little bit or having them quarter open will help out. That means you have to open at least two windows on the one side to the other, because the air that comes in also has to escape, and then the pressure will drop. So if you can open up all the windows somewhat throughout the house, then many times if the tornado's close by, it will alleviate its pressure and just mess the inside of your house up, and you end up escaping without any property damage at all. So that doesn't hurt, and that should take about 20, 30, 40 seconds quickly, and then run underground into your basement. Okay, so the other method is just to get in your car and drive away from the motion of tornado. So if it's coming at you, well, drive away from it. If it's going away from you, well, I mean, you still can drive away from it too. Take important belongings. Leave everything else behind. Your house destroyed is better than getting killed or injured. So you have to make up your mind. Some people don't want to leave their house, they're willing to die, then okay, I guess so be it. But if you're willing to sacrifice your belongings for surviving, if that's your bottom line, then do it. And then when going below ground, make sure the tornado shelter or basement is deep enough. If you have too shallow a basement or tornado shelter, it's probably better to get in your car and drive away and just take your risk of not getting hit by debris, kind of just moving randomly. And you probably just have to break all the traffic stops as long as there's no oncoming cars or people, because come on, it's a tornado, you can do all that, right? So you get far enough from the tornado and it's not in an effective range, you made it, you survived. You might not have a house anymore, but you're not dead, right? So stay calm. Tornadoes only move on the ground at 35 miles per hour. And then lastly, running away on foot, if you detect the tornado, or on bicycle or whatever, as long as you get away from the tornado, and if you detect it fast enough and you can only run like 7 or 8 miles per hour, you're probably going to be in the next town by the time it comes to your area. And again, try to avoid getting hit by debris, and you can cover up with some sort of windbreaker, even a trash bag if you need to. Several of them, because if something hits you, if it's big enough, it'll just go through anything. But chances are, like the little pebbles and small debris, they're probably going to get stopped by the tensile strength of the tarp or garbage bag or a jacket or whatever. And then, you're not going to sustain any injuries. You have to just run through the wind. And yeah, it won't be pleasant, but it's better than just sitting there and worrying about it. So as long as you get away from the tornado and you're out of range, then it's really just going to keep going and dissipate, and you can talk about it, right? So these are like 9 techniques, but keep an eye on the barometric pressure, and then figure out a way to get out of there or hide or go underground, because after all, the tornado is only moving on the ground on average about 35 miles per hour. I had to fix this here. uh, yeah, I'll fix that now before ending the video. So how to detect and evade an incoming tornado. And so I set this lecture up and then realized, oops, I got a little error. So I just decided to fix it at the end here. All right, there it is. All right, thank you for watching this video, and have a great day.